our next trick, we're going to put on a panel on new energy and propulsion systems, and Tess Hatch is going to be our moderator and going to introduce herself and the panel. Okay.
Can everyone hear me? Yes, I'm getting a thumbs up. Okay, and we have our third panelist on Zoom. Can you hear us? Awesome, thumbs up. Okay, well, I know this panel ends right at noon, and we will end right at noon, so you guys can eat lunch and get back to chatting. But today, we're going to be chatting about new energy and propulsion systems. Unfortunately, we have a panel of experts to walk us through what that means. I'm going to read the intro quickly and then intro our esteemed panel and then jump right into questions. So we're transitioning from traditional energy sources to an entirely new ecosystem. And today we're going to talk through the challenges, technical, market, regulatory, and economic ahead, and then what platforms each energy and propulsion source are optimized for. So panel intro. We're going to start immediately to my left, Mr. Ben Marcus. He's the co-founder and managing partner of Up Partners. What does the period mean? Is that symbolic?
It means that we couldn't get uppartners.com, so the .partners is our TLD.
I was going to ask you that privately, but why not just ask in front of everybody? It's an early stage investor partnering with entrepreneurs, building businesses, enabling the future of multi-dimensional mobility. Ben also co-founded and was the CEO of AirMap, the first UTM system, so unmanned traffic management system for drones. He is an FAA certified airline transport pilot. Yes, he flew here from LA and he'll be flying back home. Watsonville? Is that the airport you just flew into? Watsonville. He's also a certified flight instructor with more than 4,500 flight hours. So you're a very good pilot.
Which means I don't really know anything about the topic of this panel.
Well, you're the one that actually, you had a great question that I'm going to put you on the spot. You also serve on the National Academies of Sciences, Engineering, and Medicine, Aeronautics Research and Technology Roundtable, and you're a graduate of Purdue University School of Aeronautics. Sorry, I'm a Michigander. Go blue.
Go Boilers.
Go blue. I got
There's
another
more Purdue
one.
grads in here. I know at least a few.
Oh no, we definitely, so many. Okay, wait, let's actually, Purdue's.
Purdue.
Oh,
Yes.
wow, 1, 2,
wow.
3, 4, 5. Okay, Michigan. 1, 2, 3, 4, 5. And then your son counts. 6. Okay. Oh, it was close. With Jim finally doing his job, I will take you on that. Okay, back to panelist intros. Okay, Jay, thanks for joining us.
Hi, Tess.
Hello, nice to meet you.
Nice to meet you.
Jay, you are the technology, scouting, and business development leader for the Ford Motor Company. So you are a Go Blue. You're a Michigander.
I work out of the Palo Alto office.
Okay. Okay.
I'm a Stanford guy.
You are a Stanford guy. You earned your BS and your MS in mechanical engineering, specifically controls system design from Stanford. Go Trees, Cardinals.
Cardinals.
And an MBA from Cal. Who are you going to root for on Saturday?
I always go with the undergrad, so
Okay.
Stanford.
Okay. Hopefully see you at the game. Your broad work of experiences have encompassed garage startups to Fortune 500 companies such as Microsoft and Ernst & Young. Coincidentally, your first job was with Ford in Dearborn, Michigan for many years, but now you're back in Palo Alto. You live in San Francisco and you enjoy cruising in your 1966 Ford Mustang convertible.
Nice.
Nice.
I'm a Ford guy. So
Nice.
Go Blue, but maybe the other blue. Maybe I can ask how many Stanford people? Okay.
Yeah, we got to get a number of those too. And Levi, am I saying that correctly?
It's Levi. Fairly straightforward, just like the jeans.
Okay. Okay. Levi, thanks for joining us virtually. Where are you calling in from today?
San Francisco, so not too far away.
We're a little south. I gotta say our view is probably a lot better than yours right now.
You should come check out our office sometime and you can find out.
Levi, you are the VP for Policy and International Outreach at Ample Inc. which is the author of The Great Race, The Global Quest for the Car of the Future. And you are a regular contributor to Wired, The New Yorker, and other publications. Levi is also a former member of the Obama administration, Department of Energy, senior advisor to Valence Strategic, and joined Ample from the World Economic Forum, where he was leading an initiative on decarbonizing manufacturing. So we have a group of experts here to talk about energy and propulsion systems. So let's first start with a foundation. I want to create a framework and a playbook for this conversation. We're going to go into, what are the types historically and in the future, and what created this transition? So what created this energy transition that we're going through at the moment? Ben, maybe I can start with you.
Oh, that's a big question. Well, I guess I think there's probably two things that are accelerating the energy transition right now. One is the very stark reality that we're facing the very significant threat of climate change, and so I think that's pushing the demand for an energy transition. And then I think the second is just technological progress. The technologies exist now to make this transition. I think we've seen photovoltaic cells, for example, become actually efficient and useful recently. And that's leading to all kinds of green energy production, green hydrogen, and when you have renewable sources of electricity, you can create all kinds of great other fuels. So anyway, so I think it's those two things.
So I'd love to dig into this. Ben mentions, and Jay, I'm going to pop it over to you. Ben, you mentioned battery and hydrogen. And 10 years ago, what were the options? What were the options we had available, Jay? And today, what are the new options that we're finding also available for any vehicle? We're going to do vehicle agnostic.
Okay, but just coming from maybe the vehicle perspective, because that's kind of where we're focused. I guess 10 years ago, the choices really were limited, right? It was pretty much ICE engines, gas or diesel, more or less. Those were the choices. But what's recently changed, I agree with Ben, it's a lot of technology changes. I mean, we put out an EV vehicle in 1998, right? Ford Ranger EV. Probably not a great vehicle, but it was an EV. But it was probably way before its time. The technology wasn't there. The battery costs are too high, et cetera. Actually, it was nickel metal hydride batteries rather than lithium ion. So you can imagine it wasn't a 300-mile vehicle. But the technology is caught up, right? So it's given us a lot of choices. But I would say that in our industry, the horse is out of the barn in the sense that it's going, electrification, right? Battery electric vehicles. I know there are a lot of others that are looking at hydrogen, maybe in Europe or Japan, Toyota, others are looking at other propulsion systems. But I think more or less for us, our bet's on electrification, and I think that's the bet that most of our peers are also making. And maybe I would add one thing to what Ben said before. Another thing that really changed for us is Tesla. I mean, it just all these things happen. Technology caught up. Regulations, policies, et cetera, global warming. All those, of course, converge. But in our industry, what was a catalyst was just a simple word, Tesla, right? I mean, they put out something great, and we had to catch up.
So we have a tailwind of climate change that is catalyzing this energy transformation. A big one is batteries and the cathode and anode chemistry and the work between them. We're just optimizing batteries a lot better. Levi or Jay or Ben, we're also discussing hydrogen. What's new or different about hydrogen recently? What's been the tailwind or the technical catalyst there?
Well, that's an interesting question. I would first like to start though by saying that, Jay, I love my Ford Mach-E. It's fantastic car. So we appreciate the good engineering that is still being done in Detroit. Honestly, I'm not a hydrogen guy. I'm more of a batteries guy. I would also just add to the previous answer by saying that I think that the number one driver behind this change in the industry is regulatory. I mean, it is all about policy. None of these industries would exist without policy. We can talk about climate change, but climate change doesn't really get us anything unless you have those policy drivers in the renewables energy space, in the automotive space. And increasingly, you're looking at policy drivers in areas like aviation. And so, I think that's actually really great for people who are investing, because policy drivers tend to be relatively long term. So you can look into the future and you can invest on theses that are, relatively durable. As for hydrogen, I personally, my perspective is that what has changed in the hydrogen space is that hydrogen is probably not going to be a solution for light duty vehicles. It's not a great solution for light duty vehicles going forward. Batteries have become so cheap, they've become so good that they've kind of taken that prize. And there used to be a real competition between hydrogen and batteries. Going forward, I don't think that's much of a question anymore. That's especially the case because of what's happening in China with battery swapping. And my company is also doing battery swapping here in the United States. Hydrogen infrastructure is really expensive. It's not integrated with the grid. It's a totally parallel infrastructure. It's very difficult to set up. If you look at battery swapping, you get all of the benefits of hydrogen in terms of speed for light duty vehicles. And you have integration with the grid in a way that's actually even more powerful than what you're seeing with current electric vehicles, because battery swap allows you to have these battery banks that provide static energy storage for renewable energy that is not baseload power, it's intermittent, and we need a place to store that energy until it's needed, and we need a way to dispense it very quickly. So, I think what's changed for hydrogen is a shift towards heavy duty vehicles and also industrial applications. And I want to just round it off by saying I'm actually a huge fan of hydrogen. I think that we're going to need lots of hydrogen. We're going to need it in a lot of different sectors. We're going to probably need it for aviation. We're probably going to need it for heavy duty trucking. We're going to need it for shipping. We're going to need it for industrial spaces like steel production. And so, I would invest heavily in hydrogen. I would invest now in hydrogen. I think that the payoff is probably going to be 5 or 10 years in the future, but people who have that patient capital and who are willing to stick with hydrogen will probably do very well, by 2030 or 2035.
Thanks, Levi. Appreciate the double clicking on hydrogen, battery. And there's two things that you started to dig into on the regulatory side and on the vehicle per energy side. Before we do that, and we will in a second, Ben, you also suggested adding sustainable drop-in fuel replacements as part of the discussion, in addition to battery and hydrogen. So before we move to these next two parts, can you expand on what you mean there?
I think so far what we're talking about is fuel storage, batteries, hydrogen, or energy storage, right? Batteries, hydrogen, or some other type of liquid fuel. And so many established industries, whether it be shipping or aviation or whatever, run on fossil fuels today. And the transition to some other type of electrification, electric motors instead of internal combustion engines, whatever, is going to take a long time. So I think in the interim, while we bridge to a more electric motor driven industry, there are opportunities to create sustainable drop-in fuel replacements, whether it be from municipal solid waste or from hydrogen, combining hydrogen with carbon dioxide to make alcohol, all these kinds of things. So I think that's another very investable theme right now, not just for aviation, which is obviously something I'm passionate about, but for many other domains. Road diesel, we're seeing road diesel being created from municipal solid waste, and other feedstocks, forestry waste, agricultural waste, manufacturing waste. So that's an exciting space for us too.
Great, thanks. So Levi, you mentioned a big piece of here, which is regulation. And you have the background to provide us sort of an overlook of what's the foundation, the tailwind, the headwind, pun intended for the aerospace folk in the audience, that regulation is providing for these new energy propulsion systems.
Well, I think that you have different sets of regulations, right? On the one hand, you just have fuel economy requirements, and electric vehicles are going to be critical for automakers in the United States, in Europe, and also in China to meet those fuel economy requirements. In some places, you have slightly more aggressive and targeted regulations. California was a leader in this with what's called the zero emission vehicle mandate. California in the late 80s, 1990s, started looking at the possibility of not just reducing emissions from light duty vehicles, but actually eliminating them altogether. And, you know, at the time, that was really kind of a pie in the sky idea. They realized that in order to do that, they were going to have to be very clever in harnessing the power of the market, but also wielding the axe of regulation at the same time. And the way that they did that is they created this credit system that I'm sure Jay is very familiar with. They kind of live and breathe this stuff in Detroit, where every time you sold an electric vehicle, you got a credit for that. And you could buy and sell that credit. It had a certain value on the market. Tesla has made an enormous amount of money off of selling electric vehicle credits to automakers that are not producing enough of these credits to comply with California's regulations. But you know, just to round it out, I would say that California created what's called a synthetic market, where they kind of internalized the positive externality of research and development that was being done on electric vehicles by certain pioneering manufacturers. And Tesla benefited from that more than any other manufacturer, but you also had other manufacturers who took advantage of that. The end result was companies like Ford, but probably not going forward, buying hundreds of millions of dollars, eventually billions of dollars of electric vehicle credits from companies like Tesla that got in early on electric vehicles. So that system has been largely adopted in China, and similar systems are being mirrored around the world. Generally speaking, there is only one direction for global fleet emissions, which is down. And every automaker knows that they have to invest very heavily today, ideally 5 years ago, in order to meet the increasingly stringent requirements for fuel economy and also ZEV requirements in certain countries around the world.
That was a lot there.
Yeah.
As the Ford auto guy, what do you think?
Regarding policies?
Well, regarding policies, you even mentioned Tesla a handful of years ago, changing the way that ground-based vehicles, so we'll say cars, approach propulsion systems.
Yeah, so I won't talk too much about the policy side, I guess. It's not really a strong suit of mine, but in terms of technology side, yeah, I mean, I guess, a tier one friend of mine asked me, why such a, revolution in the auto industry, but not so much in the tier one industry, and I just said again, Tesla, right? You don't have a Tesla, right, breathing down your neck, right? They're a really good competitor, right? Now we have Rivian, right? They're a really good competitor, and I think we've had to play catch up for a little bit, but I really feel like we've caught up a good amount of that distance. I don't think we've passed them or anything, but we caught a good comparison. Mach-E, I think, is a great example, and we're really leveraging our strengths, right, to be a leader in the electrification field, right? So, Tesla, they're going to have their customers, and they're probably early adopters. And Rivian, they're going to probably have their customers, and likely maybe a little less early adopters, but still relative early adopters. Ford Motor Company, we're mass market automotive manufacturers, which means we sell to the mom and pops, the folks in Oklahoma, Texas, et cetera. And how we can make it comfortable for them to buy an electric vehicle, right? Because they're not likely going to buy a Cybertruck, right? That's going to be a different crowd. Even the Rivian, RT1, right? I saw one. It looks about the size of a Ranger, right? That's not going to work for the F-150 folks, right? So, what we try to do is make it comfortable for the folks that buy your F-150s, buy your, Mustangs, to buy a Mach-E, right? Mustang Mach-E, to buy a F-150 Lightning. Buy the E-Transit, right? Big focus on commercial fleet customers, because that's a huge, business of ours. We're number one, actually. So it's about making the experience and the vehicle comfortable, right? right? So when we showed the F-150 Lightning at our office in Palo Alto, we had the press and all that, and so we got the usual response from them. But once they left, what we did was we hosted a bunch of early the pre-order customers. And I mean, it was great seeing them there, just climbing over the vehicles, asking all these questions that you and I and would ask, and they really liked the vehicle a lot, right? They felt comfortable, I guess is a good way to put it, right? They could see themselves buying an electric vehicle, right? And that's our focus, right? Really to approach selling electric vehicles to the mass market, right? And make it a comfortable experience.
Can I chime in for a second? So Jay, I have to say, the Ford Mach-E is a fantastic car. I love it. I love driving it. I think it looks great. The thing that I really don't love is refueling it, repowering it, and charging it is just an absolutely terrible system. It takes too long. It costs too much. Most of the time I'm paying the equivalent of about $8 a gallon to use public recharging facilities. And currently the electric vehicle ecosystem as it's configured in the United States is really targeted towards a Tesla buyer demographic. It's an affluent suburbanite that has a place that they can park their car and charge it overnight. The majority of Americans don't have a place where they can park their car and charge it overnight, whether they live in a multi-unit dwelling, whether they park on the street. Despite the fact that we are probably the country with the most garages per capita in the world, a minority of Americans have electrified garages. So how are we going to get past, and of course I have my own ideas. I think battery swap is the way to go. But what is your guys' plan to get past that horrible customer experience of waiting around for, I mean, the last time I charged my electric car, I got the equivalent of, 6 gallons. It took well over an hour to charge at a so-called fast charger, and I paid, $8 a gallon equivalent. And that is not a winning proposition for transitioning consumers from very convenient ICE vehicles to more environmentally friendly electric vehicles.
That's a fair point. And just to cover your battery swapping, so we do look in that area. I guess it's not a focus right now. We've looked at Better Place in the past. So so we know the space. We know in China they're doing it. It seems to us more on the commercial side, maybe for buses, maybe for commercial fleet operators, they might be able to do some kind of battery swapping operations. But in general, we haven't seen that kind of move in that direction yet, and we could be wrong, right? We've been wrong before about a lot of things, so it's not to say that we have all the answers. But what we see as the experience is, building out the charging infrastructure, right? The charging network, doing the deals with Green Lots and others, Electrify America, Ionity in Europe, all right? So really partnering on the charging infrastructure. And yes, it probably takes too long still to charge, even with DC fast chargers, but the times are getting shorter and shorter. There are more and more sites. So, we're trying to increase the convenience of that, right? And there are a lot of people that still charge at home and then at work. A lot of our office colleagues do that, right? They charge at home, come to the office, charge in the office, go home, do it again. And it's, except for the maybe trip to LA or something like that, then that's sufficient for them. And then when they do go out, then they do need a public, charging infrastructure. But yeah, so point taken, it's too long. It's not quite the experience we want yet. We're trying to, lower the resistance, and, by putting more charging networks out there, helping the customer when they buy one of our EVs to, get the chargers put into their homes. So that they can charge faster. So we have contracts that come out, electrifications, et cetera, installers. We have deals with Sunrun. If you want to make your house solar on top of that. So just trying to lower all the barriers to entry, right, as best as we can. But yeah, you're right. There's still probably a gap to the gasoline experiences, which is what everybody wants, right? So
I just had one thing. I get to see a lot of really cool ideas, maybe 150 startups a month that I get to look at. And we're seeing so many ideas to solve this charging problem. I think battery swapping will certainly have its place. Fast charging will have its place. There's chargers going into parking garages all over the place. I know all the major parking operators in America are putting chargers in their parking facilities. But one of the interesting ideas I saw recently is essentially similar to battery swapping in the sense that you can have grid-tied energy storage that's sort of trickle charging at nominal rates, and then take all that power from that battery and dump it into a vehicle battery, and then you can put these things at people's homes. You don't need any utility improvements because it's just using like normal power. So I think there's a lot of ways to handle it, and I think that there's room for all of them because certain vehicles will be well suited and certain operators will be well suited to battery swapping, others might not be. So I think it's broad. The other thing I want to touch on, and I think this course has actually illuminated this, that I actually think a lot of this is not policy driven. I think policies have their place, but I think a lot of it's actually being driven by demand. I think people really want to decarbonize. And I think that the OEMs are feeling that, the demand from their customers. I know some of our partners, for example, Alaska Airlines has made a commitment to decarbonize by 2040. And that's not specifically being driven by any one policy. It's because their customers want them to decarbonize. And other of our partners too, like Six Rent-A-Car, for example, same thing. So yeah, I think that commercial forces are sometimes even stronger than policies, and those policies that provide incentives, not just a mandate, but an incentive like for aviation, the Corsia program, which basically is like a carbon swapping thing for aviation, or in California we have the what do you call it, the low emission credit scheme. In the UK they have the renewable fuels tax credits. So there's a lot of really interesting government subsidies going into helping this transition be a profitable exercise for everybody involved.
Well, I am confident and looking forward to Jay's team at Ford and the companies you're investing in, Ben, to solve the ground-based battery issue. Zooming up, and another example of your climate emission goal is United, along with Alaska, also by 2030, and that's why they made a $6 billion pre-order to Boom Supersonic that runs off of SAF, sustainable alternative fuels. So using that trend and zooming out, then from an air perspective, all of the aerospace folk in here, can we have a similar conversation in the 5 minutes we have left? And I do want to hopefully grab some audience questions, or you can find the panelists at lunch. Sorry, Levi, you don't get to have lunch with us. From an air perspective, all the flying cars are really battery driven? Is it going to be battery also? Or tell me about SAF, tell me about from a drone, plane, supersonic perspective.
Well, first of all, just I love Boom Supersonic. Very cool to go fast.
Remember, I'm an investor.
Congratulations.
Okay, whatever you're about to say.
No, it doesn't have to run on SAF, right? It can run on fossil fuels too. And every airliner out there can either run on fossil fuel or SAF. But
I'm kidding.
So sustainable aviation fuel, again, I think is going to play a role in bridging aviation to a decarbonized future. It's kind of a band-aid because it doesn't really fully decarbonize things, but it is a good way to eventually get to what I think will actually be a zero carbon aviation future, which is going to be on hydrogen. And the big airliners are not going to be able to use hydrogen fuel cells because fuel cells don't work when you need that much power, you need to move that much weight somewhere. So they will combust hydrogen in turbine engines the way that they combust fossil fuel in turbine engines, but that will also be zero carbon. It will have interesting other climate change effects. We're learning now about contrails actually contributing quite significantly to global warming, and combusting hydrogen will actually create more contrails than combusting fossil fuel.
Shoot.
So that's something else that I think needs to be explored. But yes, that I think is the eventual future. Then coming down to more regional aircraft, I think hydrogen fuel cells will play a role in that sort of, up to 50 passengers, up to 250 miles kind of range. I think will be suitable for hydrogen fuel cells. And then I think just like light duty vehicles on the ground, when we talk about intra-city transportation with urban air mobility, eVTOLs, those will generally be battery.
Well, with that, I said you would have lunch on time at noon. Howard, would you like to ask a question?
Yeah, I'd like to ask a question. Maybe we have room for a couple questions here. Okay. But so question to Levi. Thanks for joining us, by the way, Levi. So as a kind of a foreshadowing of the session this afternoon on China, I know you spent a lot of time working with the Chinese on their systems. Can you do a little bit of a big picture of contrast of the approach to new energy and propulsion in the US compared with China? I mean, how are the two countries comparing, measuring up?
Well, first of all, thank you so much for the question, Howard. I think that's really important. And I think it's really important for Americans to always remember that over 80% of the charging infrastructure that exists in the world today is in China. That's 80% of the fast charging infrastructure. By comparison, we have about 4% of the fast charging infrastructure in the United States. And what you've seen in the last 18 months is a massive reorientation away from tethered charging, from DC fast charging, towards battery swapping. And it's not just NIO, it's Geely, it's the Shanghai Automotive Industrial Corporation, it's the Beijing Electric Vehicle Company. It's every automaker that's worth its salt is going to be deploying thousands of battery swapping stations between now and 2025. There are already 1,000 battery swap stations in China. Those 1,000 battery swap stations, it doesn't sound like a lot, but they operate like gas stations. They're operating at 100% capacity all the time, and they have massive connections to the grid. They're delivering way more electricity to electric vehicles than every single fast charger in the United States combined. And by 2025, the announced plans by credible Chinese actors from the state grid to Geely, they account for about 90 million vehicles worth of swapping capacity a week. There are 270 million light duty vehicles in the United States. So this is the way that by far the biggest electric car market in the world is going. We are way behind. And when I see these impressive investments, $11 billion towards electrification that places like Ford are making, I really worry that they're ignoring a high-def digital roadmap that is being provided to us by our largest economic competitor in the world, which is China. They're 5 years ahead of us in EV infrastructure, and they figured out what the problems are, and they're solving it through battery swapping. And if we don't leapfrog the current generation of slow charging and take a note from their book, then we're just going to continue to be behind. And I think that that's a big problem.
We have a question from online, if you don't mind, Tess.
Last
So-
question, let's end our panel.
Okay, we could actually go over a couple minutes too, if there's others in the audience, we don't mind. So this is from Simon Saba. His question is for Jay, and it goes, a while back, Ford made the announcement of leaving the sedan segment. Has that changed due to the transition to EVs?
It's not changed, so it's still our direction. I mean, it's just been a consumer-driven decision, right? Just cars just aren't selling like they used to. The new sedan is kind of the, I guess, the, Mach-E's kind of getting, right? It's kind of a half sedan, half SUV, right? So I think that's the segment that's kind of taken over from the car. So yeah, we're not changing our direction on cars. There's a couple, of course, like the Mustang will keep, and because they're iconic nameplates and very popular with their customers. But I think the Ford Fusions, those kind of vehicles, at least in the U.S., probably not anything we're going to be investing in, and more kind of the Ford Focus, or sorry, Ford Escape would be more kind of the replacement for those kind of vehicles.
Please join me in thanking Ben, Jay, and Levi.